Hello everyone, I am Amit Kumar. Welcome you to the presentation of the paper called Unsupervised Approach for Zero Shot Experiments, Bhojpuri Hindi and Magahi Hindi at LoResMT 2020. This work is in the scope of third workshop on technologies for MT of low resource languages. The motive of said task is to develop an MT system for zero shot experiments. Zero shot approach is to build an empty system for language pairs where parallel corpora are small or even non-existent. This is overview of the work done. First, we will introduce about low resource NMT system and we discuss some solutions for such low resource NMT system. Next, we discuss some related works. Then we discuss our proposed solution, and then we discuss corpus statistics, and then experimental setup we use to conduct experiments, and then we present some results. At last, we finally conclude with some points. So we start from introduction. Extremely low resource languages are the languages which have very little data available or even no data are available. Now the challenge is to develop an empty system for such languages. An empty requires a certain amount of parallel corpus to train the model for even low resource languages, and its challenging task is to create the parallel corpus from scratch. Creating parallel corpus requires language experts and it is expensive. So the solution is using unsupervised approach. Unsupervised domain adaptation is one of the best approaches to build zero-shot and empty system. Unsupervised domain adaptation is the task of training a model on level data from a source domain to achieve better performance on data from a target domain with access to only unlabeled data in the target domain. Coming to related work, to the best of my knowledge, there is no relevant work I found on Bhojpuri to Hindi and Magahi Hindi NT system. But there is one thesis work that covers the English Bhojpuri SMT system, and this thesis report also covers the language technology resources for Bhojpuri languages. And the second workshop on technologies for MT of low resource languages organized a shared task on Bhojpuri English and Magahi English MT system. But in both of the works, they used some parallel sentences to train the model. Now coming to the proposed approach. Our approach is unsupervised hybrid approach. It is the hybrid approach of domain adaptation using similar languages followed by two iteration back translation using monolingual data. So we use the Nepali Hindi language pairs to train the model. We consider Nepali Hindi as source task and we apply the Nepali Hindi train model on Bhojpuri Hindi and Magahi Hindi directly to evaluate the system. Motive behind using Nepali Hindi is Nepali Hindi, Bhojpuri, Magahi are related languages. All these languages belong to Indo-Aryan families and the speaker of these languages shares the border from long period of time. So there is a maximum probability of language relatedness. So coming to the two iteration back translation using monolingual data. In the first iteration, we translate the monolingual Bhojpuri data to Hindi using Nepali Hindi trained models. Then we combine the translated Hindi Bhojpuri monolingual corpus with Hindi Nepali parallel corpus and create the synthetic Hindi Bhojpuri parallel corpus. Then we train the transformer model using Hindi Bhojpuri synthetic parallel corpus. Now coming to the second iteration, in the second iteration, we vice versa repeat the steps for Bhojpuri to Hindi language pairs. Now then we follow the same procedure for Magahi Hindi language pair for both directions, Magahi to Hindi and Hindi to Magahi. Coming to corpus statistics, we collect the Nepali Hindi parallel corpus from TDIL, Opus and WMT 2019 similar language translation task, and the rest of the data were provided by the LoResMT 2020 say task organizers. This page covers the experimental setup used to execute the experiments. We used fair sequence modeling toolkit to train the model. We trained the model for 100 epochs, and these are the hyperparameters with their values that we used in the experiment. Coming to the results section, we use unsupervised vanilla transformer approach to compare with our hybrid approach. Our system achieved considerable improvement for Bhojpuri to Hindi and Magahi to Hindi language pairs. It also shows little scores improvement for Hindi to Bhojpuri and Hindi to Magahi language pairs. Organizer also evaluate our hybrid approach using precision, recall, and F-measure metrics. Finally, coming to the conclusion part, we conclude with some points. Our results shows that by using domain adaptation for similar languages, an unsupervised approach gives varying degrees of improvement for translation of zero-shot languages. We note that similar language data and the models can play a significant role in future for creating the resources and tools for extremely low or zero resource languages. All the results conducted are reproducible using the publicly available FAIRSEC sequence modeling toolkit. This is the list of references used. Thank you everyone for listening.